Hey there, welcome to a video that covers pages 4 through 5 of section 3.6 notes on chain rule. So here's page 4, example 9, and we are going to evaluate this derivative. We have 1/2 f of x times g of x at x equals 5. So clearly there is a product rule happening here. And remember, when we do product rule, the 1/2 is a constant, so we can kind of just push that off to the side. But you're going to take derivative of the first function times g of x plus f of x times g prime of x. So actually there is no chain rule happening here. This is just simply product rule. And if we plug in 5, you have f prime of 5 times g of 5 plus f of 5 times g prime of 5. F prime of 5 we know is 2. G of 5 we know is 7. F of 5 we know is -4. And g prime of 5 we know is 10. Work it all out. You get 1/2. 14 is -40. Half of -26. And of course, we got ourselves -13. So basically, it's just a lot of plugging in after you take the derivative. So this is the kind of problem you could see on the AP exam multiple choice. So that way, you can't really kind of work backwards using the antiderivative, which we'll talk about in the spring semester. It really forces you to use the product rule and know it well. So yeah, f prime of x times g of x plus f of x times g prime of x. Plug in the 5. You got the values up above that we substituted for. Work it all out and just kind of make sure I did this correctly, and it looks like I did. Yeah, and 14 plus -40, -26, half that's -13. Now for part B, you have f of g of x, and that is going to require a chain rule. Here's the reason why. The derivative of a composite function is this, right? That's how we define chain rule. Of course, we're going to plug in 5. And I locate g of 5, that's 7. So that's f prime of 7. G prime 5 is 10. And f prime 7, of course, is -1. You just get -10. Hopefully that makes sense for that one. We do have chain rule happening a couple more times here. Hopefully you realize that's just g of x cubed, seen with 3 to the front, squared, but it's going to multiply by 3 to the inside, which is that. And of course, we're substituting 5. What's g of 5? That's 7. What's g prime 5? That's 10. 3 times 49 times 10. 3 times 4, 90. Use a calculator if you need to. That should be 1470. Then lastly, we have 1 over f of x. You think of that as f of x raised to -1 power, or you could do a quotient rule, your choice. But we'll use chain rule again, just like how we did chain rule in part C, right? So move -1 to the front. You're going to raise that to -2 power times u to the inside. So basically, it's just negative f prime 5 over f of 5 squared. Remember, you raised it to -2, so it should go on the bottom. F prime 5 is 2. F of 5 is -4. You get yourself -1/8. So there we go. So you have a chance to practice on homework. And then lastly, remember that we said that results for trig derivatives are only valid when you're in radian mode, because the results are based on the fact that we have this, wages in radians. So we did that derivation a while ago, or in 3.5 minutes, sort of in the week. If you look at the graph of y equals sine x, and its derivative of x in the radian degree mode, of course, that's radian mode, and if you were to do that in degree mode, you wouldn't really see anything. Now, why is that? So the derivative of sine x, which we know is cos x, cos x is right there. But if you switch your mode to degree mode, you see nothing. So what's happening here? Now remember, to convert to degrees of radians, you multiply by pi over 180 degrees. So we have x degrees, you'll multiply by pi over 180 degrees to get the n radians. So it's pi x over 180. Y equals sine pi x over 180. If you were to take the derivative, that's all chain rule, so you have cosine of that. But you got to multiply by pi over 180, which is actually a pretty small number. So basically, that pi over 180 is like your amplitude, which is a really, really small number. And there is something there, but it's just really, really small. So you really can't see it. So again, you want to make sure that we keep this in radian mode when doing derivative trig functions. And that's based upon the derivation we did for sine and cosine. Here again, sine h over h equals 1. We did that with the assumption that h was in radians, and that's what happened. Because if you were to take sine of something in radians divided by the angle in radians, as h gets close to 0, it does get close to 1. So we got to keep things in radians. So obviously, if we do sine of x degrees, you're not going to see it because of using the chain rule. We see that our amplitude is pi over 180. That's really small. If I do the second derivative, of course, derivative of cosine is negative sine. So you still got the pi over 180 as a constant. So you kind of leave it off to the side, and of course, derivative of sine is negative cosine. But you got to multiply by the derivative of the inside again, which is still pi over 180. So you get negative pi squared over 180 squared, or actually something like that. So that should conclude the 3.6 notes.